In this lecture, we will look deeper into BIM, how BIM works. Okay, before that, do you have this question in mind? Isn't BIM a new software? No, BIM is not a software. BIM is about a different methodology of running a project from as early as designing phase to after completion. Let's understand that by taking a look to how the traditional building construction is. In traditional approach, the architect's design will be produced in 2D drawings, and drawings will be sent to different consultants or stakeholders for viewing or to add more information in separate drawings. In BIM, after architect produce BIM model, all consultants and stakeholders use the same model to extract information. Consultants will also collaborate using the same model and produce engineering BIM models. Any updates by the architect will be reflected on the main BIM model and can be seen instantly by others. But you may be wondering, okay, BIM is more organized, but what's wrong with the traditional approach? In traditional approach, after architect completed a design, drawings will be produced in 2D and will be printed on papers in certain scale. So based on the produced drawings, engineers will create another 2D drawing and referring to the written details among seas of other information. The same set of drawings will be sent to quantity surveyor. Quantity surveyor will count components manually and produce another set of information. To detect discrepancies of data, all drawings and information will be cross-checked manually. So there are lack of data management in traditional approach, and information is losing in every steps of the process. In small project, it may seem as not important, but in medium to big scale project, the impact of data error is massive. Here are some cons of a traditional approach. Higher chance of data loss due to multiple manual amendments from design to completion stage. Harder to find information on printed drawings with crowded and overlapping information. Inability to track who is responsible for the information. Manual calculation for cost estimation. Project modification generates additional time. And poor clash detection. Multiple consultants and most clashes are detected during construction phase. So how is BIM different than traditional approach? Here are 5 key points of how BIM is different than traditional approach. The first one is drawing and data. In traditional approach, drawings are produced in AutoCAD, and these components are actually lines. So in AutoCAD, we are drawing line by line like how we draw on paper, but using computer. For example, here, we have to draw each view of the window, and if there's any changes on the elevation, you have to amend the plan view and the section view of the window too. In BIM, the component is built as 3D module, and it is actually a window with sets of information that can be as detailed as materials, manufacturer, model, and phase created. Any changes made to the window will be reflected in other views instantly. Let's take a Lego for an example of how BIM model is. In traditional approach, this Lego will be drawn as lines, and we have separate drawings for different views. The 3D produced is more for rendering with no information on the product. In BIM, the Lego is built virtually and contains set of information. So in one building, there are different sets of information for each building components. The second difference is traditional approach rely heavily on 2D drawings, either soft copy or printed, while BIM is model-based platform that allows multiple consultants to collaborate using the same model. The third one is automated data extraction. From the BIM model, we can produce bill of quantity, run solar analysis, schedules, and other data based on needs. The fourth difference is clash detection. Because consultants already built the virtual version of building in BIM model, clashes between components can be detected automatically before the construction stage. The last point that I would like to highlight is BIM is involved throughout the project lifecycle, while traditional approach stops when the construction is completed. The same BIM model will be updated based on changes on the building. In summary, what we built virtually in computer using BIM model tool during design phase is what we built physically during construction phase. And after the building is completed, the building model will be used for operation and maintenance. In the next lesson, we will start to explore Autodesk Revit, one of BIM modeling tools.
Among